What if one of the best things protecting alien life is not on a planet's surface at all? What if the real shield is buried deep underground, hidden beneath thousands of miles of rock, inside a vast ocean of molten magma? Not water, not ice, magma. When most people imagine a habitable planet, they picture something simple. A rocky world, the right distance from its star, maybe liquid water, maybe an atmosphere, and hopefully the ingredients for life. But the universe may be far stranger than that, because being in the so-called habitable zone is not enough. A planet can be in the perfect orbit and still be completely hostile to life. Its atmosphere can be blasted away. Its surface can be flooded with radiation. Its climate can collapse long before life ever has a chance. And now, scientists think some giant rocky planets may have a hidden advantage. Deep oceans of magma that could generate strong magnetic fields and help protect their atmospheres for billions of years. That means the secret to life on distant worlds may not be found in their skies alone. It may be hidden deep inside them. For a long time, the search for alien life focused on one main idea: distance from the star. Too close, and a planet is scorched. Too far, and everything freezes. But in the middle, in the habitable zone, liquid water could exist on the surface. That sounds promising, but it leaves out something critical: protection. A planet can have the right temperature and still lose everything if its atmosphere is stripped away by stellar winds and radiation. Without protection, oceans can disappear, surface conditions can become unstable, and any early chemistry that might lead to life can be destroyed. That is why magnetic fields matter so much. On Earth, our magnetic field helps deflect charged particles from the sun and reduces the damage that space weather can do to our atmosphere. It is one of the invisible systems helping keep Earth livable over long stretches of time. So, the real question is not just whether a planet is in the right place, it is whether that planet has the internal machinery to defend itself. Part 2. The problem with red dwarf stars. This becomes especially important around red dwarfs. Red dwarfs are small, dim stars, and they are the most common stars in the Milky Way. Many of the rocky planets we discover orbit them. Warm, since these stars are cooler than the sun, their habitable zones are much closer in. That sounds convenient, but it creates a major problem. Planets in those close-in habitable zones can be hammered by intense radiation, ultraviolet light, X-rays, and powerful stellar flares. In other words, some of the most common potentially habitable worlds in the galaxy may also live in some of the harshest environments. So even if a red dwarf planet has water, it may still be at serious risk, unless it has a way to protect itself. And that is where this new idea becomes so exciting. Part 3. Meet the super-Earths. The planets at the center of this story are called super-Earths. A super-Earth is not necessarily another Earth. It simply means a rocky planet larger than Earth, but smaller than Neptune. These worlds are incredibly important because they seem to be very common in our galaxy, even though our own solar system does not have one. And because they are larger than Earth, the pressure inside them can become absolutely extreme. That matters because deep inside some of these planets, conditions may exist that allow something extraordinary to happen. Not just molten rock, a magnetic engine. Part 4. The hidden ocean beneath the crust. Scientists think that young rocky planets may begin their lives with huge amounts of their interiors melted. During formation, violent collisions and intense heat can create enormous global magma oceans. As the planet cools, some of that molten material may separate. The denser, iron-rich melt can sink deeper and collect near the boundary between the mantle and the core. Over time, this can create a buried layer of molten rock called a basal magma ocean. So when we talk about hidden oceans of magma, we are not talking about lava lakes on the surface.
We're talking about a deep, trapped, iron-rich sea of molten rock, hidden far below the crust, surrounding the core like a secret shell. And on super-Earths, those magma oceans may survive much longer than scientists once expected.
Part 5. How can magma create a magnetic field? At first, this sounds impossible. We usually think of magnetic fields coming from liquid metal in a planet's core, not from molten rock. But what matters is not whether the material is rock or metal. What matters is whether it can conduct electricity and move. Under the extreme pressures inside super-Earths, iron-rich magma may become conductive enough to do something remarkable. If that magma churns and circulates, it can act like a dynamo, generating a magnetic field. That means some planets may not rely only on their cores for protection. They may have a second magnetic engine, buried above the core, inside a deep layer of molten rock. And because that magma ocean is closer to the surface than the core is, its magnetic field can have a surprisingly strong effect where it matters most. Part 6. Why this could be a huge deal. Here is why scientists are paying so much attention to this idea. The research suggests that on larger super-Earths, these hidden magma oceans could generate magnetic fields even stronger than traditional core-driven dynamos, and they could keep doing it for billions of years.
That is massive, because habitability is not just about having the right conditions once, it is about keeping those conditions stable for a very long time. Life needs time. Time for chemistry to become biology. Time for simple organisms to adapt.
Time for ecosystems to form and evolve. If a planet loses its atmosphere too quickly, that chance may be gone before life ever really begins. But a strong magnetic shield could help a planet hold on longer, and that changes the picture entirely. Part 7. Magma does not protect life directly. This is an important distinction. The hidden magma ocean is not protecting life directly like some underground refuge where organisms float in molten rock. That is not the idea. The protection is indirect. A stronger magnetic field can help shield a planet from stellar wind and radiation. That can improve the odds that the atmosphere survives. And if the atmosphere survives, the surface has a much better chance of staying stable enough for life. So the headline is dramatic, but the science is more precise. Magma oceans may not shelter alien life themselves. They may protect the conditions that allow life to exist, and that is still an incredible possibility. Part 8. A new way to think about alien worlds. This research also challenges one of our biggest assumptions. For decades, Earth has been our template for a habitable planet. That makes sense, because Earth is the only world we know for sure has life. But maybe Earth is not the only successful design. Maybe some living worlds are not Earth-like in the usual sense at all. Maybe they are bigger, denser, and more violent inside. Maybe they orbit stars we once thought were too hostile. Maybe they survive not because they are calm and gentle, but because their interiors are powerful enough to protect them. That is one of the most exciting parts of this discovery. It suggests the universe may have more than one way to build a habitable planet. Part 9. Could we ever detect this? That is the big challenge. We cannot directly look inside an exoplanet. We cannot drill into it or send instruments down into its mantle. Everything has to be inferred from mass, radius, orbit, atmosphere, and the behavior of its star. But scientists may eventually find indirect clues. If a planet around a violent star somehow keeps a thick atmosphere longer than expected, that could be a hint. If a super-Earth seems unusually resilient in a dangerous environment, that could be another clue. And as telescopes improve, astronomers may get better at spotting the signs of magnetic fields around distant worlds. One day, we may identify planets that should have been stripped bare long ago, yet somehow remained protected. And the answer might be buried deep below their surfaces,
in oceans of molten rock. There is something almost poetic about this. A world may begin in chaos, with fire, impacts, and a molten interior. And that same violence may create the very shield that helps it stay habitable later on. A planet could be born in an ocean of fire, and that fire could preserve the air above it. The universe does this all the time. It takes destruction and turns it into structure. It takes heat and pressure and turns them into possibility. And now, maybe, on some distant super-Earths, it takes hidden magma and turns it into a shield for life. So, could hidden oceans of magma really be protecting alien life? Maybe. Not by cradling life directly, but by generating powerful magnetic fields that help planets hold on to their atmospheres and survive the fury of their stars.
And that possibility changes how we search for life in the cosmos. Because the most important thing about a planet may not be what we see on the surface. It may be what is happening far below it. Beneath the crust. Beneath the mantle. In a dark, buried ocean of molten rock, turning slowly around the core, building an invisible shield around an entire world. And somewhere above that shield, under a sky that should have been lost long ago, life may be holding on, maybe even thriving. The search for alien life is no longer just a search for water, air, and the right orbit. It is also a search for hidden engines deep inside distant worlds. And the deeper science looks, the stranger the universe becomes. Subscribe to Infinite Science for more mind-blowing journeys into the mysteries of space, planets, and the hidden forces shaping the universe. Because out there, the truth is often far stranger than science fiction.